So let us now continue with our derivation of the transfer function. So we now, after solving the s minus 1, si minus a inverse, we now substitute it to this equation, the general equation of deriving the y of s. So please recall that the matrix C is negative 1 over 6 minus 4. The solved Si minus A raised to negative 1 is this. The matrix B is 0 over 1 over the S squared plus 4S plus 1 over 6. Now this is part of the Si minus A inverse. So, and then the US here plus the matrix D is equals to 1. Okay, so 1 US. Uh, the next thing that we're going to do is to simplify this equation or this fraction by combining or do the operations in the matrices. So we first multiply this matrix C with this matrix. So recalling how to multiply, it's negative 6 times s plus 4 plus negative 4 times negative 1 over 6. So ito na siya for the first element. And then for the second element of the matrix, that will be negative 6, negative 1 over 6 times 1 plus negative 4 times uh, negative 4 times negative 1 over 6 times 1 plus negative 4 times 6. Yes, so yun, lagay tayo ng correction. Okay? And that's it, no? So the product of this times this ay eto na yon. Then we just copy muna 0 and 1 here, the US. So we copy everything. And then simplifying further, this will now be equivalent to, actually, if we're going to multiply this matrix with this, so this element times 0, that will be 0 already. Okay? Yes, kasi again, no, we multiply this times 0 plus the whole of this times 1. O, yun na nga yun. So, negative 1 over 6 times 1 is negative 1 over 6. And then negative 4 times s is negative 4s. And then copy the denominator. And of course, the us plus us. Okay? And now, we combine the two terms, this term and this term. Okay, so with a coefficient of 1 here. So we have now negative 1 over 6, negative 4s, plus the whole of the denominator times 1 all over the denominator. And notice here that negative 1 over 6 can be cancelled with the negative positive 1 over 6, and negative 4s cancelled with positive 4s. And therefore, we have our ys, and then we transpose us on the other side. So this is now the output ys over input us is now equal to s squared over s squared plus 4s plus 1 over 6, our original transfer function. Okay, now here we will discuss the uh, converting the transfer function to converting the state space model to a transfer function. This is our derived state space model, wherein the given here is the for matrix B 0 and 1 up, and for matrix C it's negative 1/3 and 1/8. Of course, using the same procedure, and since we have the same matrix A, kagaya kanina, and we have already solved the S I minus A inverse, no? Na-solve na natin kanina yon. So we simply copy it here. And so we directly proceed with substituting the values of the following in this equation. So the C here is negative 1/3 minus 8. The SI minus A inverse is this one. The B is 0 over 1/2. And of course the denominator. Okay. And then plus D is 1. So that is US. So same thing that we're going to do. Simplify this term by combining or multiplying, do the operations with the matrices. So we multiply negative 1/3 times s plus 4, okay, plus negative 8 times negative 1 over 6. So that's the first element of the matrix. The next element is negative 1/3, okay, times 1 plus negative 8 times s. Okay, and so that is now the product of these two matrices. Again, copy first muna, no? 0 over 1/2 US all over the denominator, okay, plus, of course, the US here. Okay, simplifying further, we multiply again this matrix with this, and so this times 0 ay magiging 0 na tong element na ito. Okay, and so we will multiply na lang is the negative 1/3 multiplied with 1/2 plus negative 8s times 1/2. Okay, so this 1/2, ito na yun, 1/2 times negative 1/3, and then negative 8s. Okay, all over again the denominator times I already write that directly, combining this term with this term. So least common denominator yung denominator na ito multiply sa 1. So we have here s squared plus 4s plus 1 over 6 for this, least common denominator, adding a fraction and the whole number. Okay, so 1/2 times negative 1/3 is negative 1/6, na-cancel uli. Negative 8 times 1/2 is negative 4, cancel uli. So therefore, our final answer for our transfer function is we have arrived to our transfer function. Okay, and I would like to encourage everyone to try to explore the MATLAB. No? Use this example or the example in your problem in your laboratory, okay, and try to explore in MATLAB and see what the coefficients of your conversion will be. Say for example, you have your transfer function, you enter it in MATLAB and try to see what will be the coefficients of what will be the matrices of A, B, C, and D that MATLAB will give you. Okay, so that's all.